Now, when dealing with loudness of a song, it's not just about pure figures right here, what the meters on the master is showing you in RMS values, because there are other things to consider when dealing with loudness, or at least apparent loudness of a signal, or how it subjectively sounds to the human ear. Now, we have in all of these meters right here in Ableton, at least, when I play the song. I'll just pull the volume down so that I can talk and you can see all those levels dancing. So what we do have right here is, you see the levels jumping. Okay, now we have a momentary value, the ppm meter, peak value meter right there, going higher, and we have the RMS meter right there. That's the average, root mean square, average level of the signal. So we have the momentary levels of the signal and an average level of the signal. The average level of the signal is something that would, give us more information about the actual loudness, the apparent level, subjective level, or how loud it sounds to the human ear, to us. But it doesn't always have to be the case. And I will tell you why, because not all frequencies are equal to the human ear. We don't hear all the frequencies in the same level. And we talked about it in the courses past. So we as humans perceive some frequencies louder than others. And that skew also changes depending on, how loud the actual entire signal is. Now, this subject has been thoroughly researched, and we have the most famous Fletcher-Manson curves, which have been revised since then, and they show us how loud do we hear frequencies from within the entire spectrum range that the human ear can pick up. How loud do we hear, frequencies out of that range, and also depending on the level of all of those frequencies. So, just to keep it simple, if I played for you a sine wave in different frequencies, let's say in the bass at 100 hertz, then 200, 300, 400, 500, and so on up the range, and I played that sine wave always at the same level, it wouldn't seem the same level to you when you heard it, because human ears hear different frequencies at different levels. Meaning that we hear, just to simplify it, we hear mid-range frequencies better than others. So meaning those sound louder to us than hearing just bass and highs. Now, what does that practically mean for us? Knowing that we hear mid-frequencies better, what does that mean to us? Well, that means that, having two different songs that, when we master them, mix them, limit them with a limiter, whatever, that, apparently have the same RMS level, they might seem quite different in the loudness that they present to us. Subjectively, they might sound quite different in one being like sounding way louder. Now, why? Well, because that other song that sounds louder has more frequencies in the range that we hear better, that we perceive as louder. Meaning that if we have a song with a lot of mid frequencies and a song with not so many mid frequencies, the one with more mids is going to sound louder. Now, you should take that into account when producing music, knowing that levels and loudness actually comes also from the subjective perception of sound that the humans have. So we are biased to it, and nobody on this planet hears the sound the same. All our earlobes are different, our ear canals are different, the mechanisms we have in our ears to actually perceive the sound, and then the brain decoding it for all of us, it's quite different. Still, there are certain characteristics to the sound that all of us humans perceive the same, and that is, which frequencies averagely we hear as higher in volume than others, even if those frequencies, even let's say if I played you a sine wave, as I said, at the same level, at different frequencies, you would perceive some of them as louder. Now, this correlation between frequencies and which ones seem louder actually changes as the entire signal goes louder. So meaning that if I play that same sine wave now, again, much louder, for each one of those frequencies, now that correlation between which one we hear louder and quieter would change. And you can see that in the graph in the Fletcher-Manson curves graph right there. Now, just to have that in mind when you're producing music, and maybe as a beginner, and your songs have too many mid-frequencies or too few mid-frequencies, too few elements with mid-frequencies, that's going to tell you something. So what I always suggest is using an analyzer and looking at other people's songs through analyzers, and that just helps you not to get fooled by your own perception of the song. So when you play something of somebody else's and you see what it looks like in an analyzer like that, and when you actually listen to hundreds of songs through analyzers, listening and looking at them at the same time. Let me just pull on the master volume down like that. Like that. It might just help you, discern some of the errors you might be making, in production. And analyzers are quite, flexible today. You can change a lot of the settings and make them, display the signal the way you like it, the way you're used to it. So you can find a setting that works good for you, and then just, make sure that you use that setting all the time so that you can discern some things. Now, analyzers are not something that you should uphold to the greatest of standards and just mix your music so it looks good on an analyzer. Music needs to sound good, first and foremost. But analyzers are a thing that can actually help you. Having two senses evaluate on something could be much better. So this is a really helpful tool. It's like trying to measure something, but using your thumb and not an actual, measuring tool like a meter or something. So this is a tool that helps you measure. Now, specifically, this tool helps you measure the frequencies and their amplitudes in the signal that you're playing. So you can do a test by yourself and see, what the frequencies sound like to you. Open up a synthesizer, make it play a sine wave, and it's always going to stay at the same level. So just play a higher note every time you play it, and you will see that some of those notes are going to seem much louder, especially when you get to this area, 1 to 2, 3K. You're going to see that area is where you actually really hear the frequencies loudly.